Hello everyone, welcome back to the channel. Today we are diving deep into the powerful AI plus FPGA workflow. How to recognize handwritten digits using a deep learning model deployed on a Xilinx ZCU104 FPGA with DPU acceleration. So this video is packed from Vitis hardware design, PetaLinux setup, model training, and quantization using Vitis AI. So all the way to deploying on the real hardware. So if you are into AI, embedded systems, I just want to see AI running on FPGA, just stay tuned and let's get started. Before we start building anything, it's crucial to make sure all our tools are compatible. So in this page, you can see different versions of DPU IP versions. So we are using Vitis AI 1.4. And so the correct matching versions for the Vivado and Vitis AI versions are 2020.1 or 21. So for 2020.2, we are using Vitis 1.3 version. So as we have DPO IP versions 3.3, so it is both compatible with 2021 and 2020.2. So yeah, so let's get started with Vitis Vivado, Vitis PetaLinux 2021.1 versions, and DPO IP 3.3 version, and Vitis AI 1.4 version. So you can always refer to this official or compatibility table on Xilinx website to double check your versions before proceeding. We will begin by setting up the hardware using Vivado 2021.1 and let's start creating a new project with ZCU104 board. So click on create project and click next, and here I'm using the A drive, and now let me choose one folder for this, and I have created one handwritten digit recognition folder for this, and my project name is hardware for DPU and handwritten digits recognition. And next, and next, and go to the boards, choose the ZCU104 under here, ZCU104. Yes, now click on that and click next and finish. And here the project is created. Once project is created, integrate the DPIP block from the product repository. So in this repository, you can find the all the files which I'm mentioning in this video, and the here now we can find the DPIP from this DPIP repo folder, and the repo link is provided in the description. So let's add the DPIP repo to the project. Click on the settings and go to the IP, click on repository, click on add symbol, and here I've had the IP in this DPIP repo. Click select. Now we can see the IPs was added here, and then okay, and let's oh here small. Let me just minimize it. Yeah, cool. Now click OK. Now the IP was added to that. Now in the from the Git repo, you can get the IP flow. And now if you go to the Git repository, here you can find the block diagram script, which you can run in the TCL console. And if you see my script, it was in the A drive and had it is in this block. So I'm going to change the directory in the tickle command to locate to that. And cd handwritten results and it's block script. Yes. Now source DPU x1 X1 CU104.tickle. And now I'm running. Now the block design is being created, and then it's gonna take a few seconds. And now if you see the block diagram is fully created, and here we have the Jink PS here, and then we have the DPU IP which we added from the Git repo. And let's see what is there in the DPU IP. For our design, we are using DPU IP single core. So to optimize the let's say limited VRAM, and we are using the RAM usage very low. And also here we are having the DPU IP 30 Ultra RAM used for DPU 30. And if you are using the dual core, you have to choose to 40 Ultra RAM and just enable the dual clock here. If it is not enabled, and yeah, here it is using the XCI protocol for the control, and here it is having the data 0, MX is data 0, and MX is data 1 for the weights and activation functions to transfer to the GPS. And along with that, we have here the DP interrupt signal here. So yeah, so in our model, we are going to use the ReLU for the ReLU, and actually we are using for the final output, we are using softmax, but here we're keeping the softmax score at 0 because we are going to run the final softmax function in the CPU side because it's going to take a lot of resources. So to optimize that, so as of now we're using softmax 0, 0, and then I'm going to explain the further where we are going softmax. So just okay, and then go to sources, and let's just create the HTML wrapper here. Let auto generate. Okay. Once it is being updated, and here we have the wrapper which is being created, and then click on generate block design and choose auto context per IP, and just choose maximum cost to make it work faster, to generate faster. Just click generate. So yeah, now it is done. Go to design runs. You can see auto context models were generated, and it is being synthesized. In the meantime, let's go to settings and change the implementation strategy. So in order to avoid the timing errors, we are changing the implementation strategies. So here under this, choose the egress performance, explore physics post route, and go to the here we need to go to the post route. Yeah, here go into the post route physics design, and here change it to the aggressive explore, and then click OK. So here in this you can change the strategies of implementation design according to your specific design. So yeah, let's click OK. So yeah, so we have changed the strategies, and now we can happily generate the bitstream. Generate bitstream and click OK. And now bitstream is being generated, and when it is generating, here you can see, yeah, here as we change the performance export strategy, here we change, so it's based on that it will generate its design. So yeah, now it may gonna take around 45 to 50 minutes to generate a bitstream. So in the meantime, let's set up the Ubuntu environment. to install the PetaLinux. And if you guys have not the Ubuntu in your system, you can just directly install it from the Microsoft Store and just search Ubuntu in this. And for the PetaLinux 2021.1 version, so Ubuntu 20.04 version will be supported. And also to use this in your system, you need to enable WS subsystem Linux. And so for that, just click on Windows R. So and then this run, enter the optional features dot exe. Yeah. Now this will be pop up, and here under this you should enable the Windows subsystem. And in this, where is this? Yeah. Here you're gonna need to Windows subsystem Linux. You need to enable this, and then you can install that, and it will support this Ubuntu on your system. And then just click OK, and yeah, and it will ask for a system restart, and just restart your system. So once you're able to install, and when you open the Ubuntu, so it will ask for your username and password, etc., password and everything. And yeah, that's it. So after that, we just ask you open your terminal. So you can just use as a terminal in this. So if you want the desktop version, and you can use a boot image, completely separate boot image, everything, or you can use the virtual machine for that. So, but yeah, I thought this is a easy process for you to install Ubuntu. So yeah, in this also, and this you can use everything. And if you see all the in from this, you can access the C drive, D drives of your Windows systems and all. So yeah, so once this Ubuntu installation is done, so here we have the some additional requirements which we're going to need. So you need to install all these packages. So this is available in my GitHub repo, the documentation. So just update it and upgrade, and then you need to set this to the dash. So it won't send in this, yeah, run this all these commands and install the all the required packages from this. And yeah, and then next set up the TFTP server. Yeah, from here to, so these are the requirements which you're gonna need. And yeah, and then next we're going to do for the PetaLinux installer. So for that, and you need to install the PetaLinux installer. So PetaLinux, Linux, download, and from the AMD. In the AMD app search, you need to install the PetaLinux, and just go to the downloads and just choose archive folder, and it's gonna load, and we're gonna need the 2021.1 version. Just click here, and then yeah, install this. And yeah, and apart from that, if you want, if you have some additional data to download, you can also download these uh, SSD cache and download images. This SSD R64 and download updates here. So these are the artifacts. So which it is needed for us to, if you want to run the Petalinux in the offline without using network, then these both are necessary. Otherwise, it is not required to download too, because from the Petalinux installer, it will get these from the online. So yeah, but to avoid the network issues and all, it's better to install this. And here we have all the board support packages, and for the ZC104, since we are running DPU on that, we have the separate board support packages which is tiered. which is target reference design support packages, and that package was the which here I provided in the Git repo. You can install, you can get the board support package of the ZC104 TRD flow from this. So yeah, so for, if you see PetaLinux, for it is creating the PetaLinux folder and just giving me the permissions to install in that, and then yeah, just give this executable file for the PetaLinux install, which was downloaded from the AMD website, and just run and just give the command, and here you have to just give the directive in which folder it has to download it, and then yeah, after that just go to, and yeah, let's see how once you download it, let's see how the setup was done. And yeah, if you go to the PetaLinux and others, and continue font version, and yeah, and we have to source the settings, and now we can see it was, and now PetaLinux create habit, and here you can see the commands which we are able to share, use it to create the PetaLinux projects. And now for we have the different templates for the jing and all, and then yeah, so this is the main PetaLinux, and along with the other elements which are used to create a PetaLinux project. And if you have failed to load this PetaLinux thread, then there might be some mistake in the installation, or if you're facing any issues, then sometimes it might be the network issue also, because if you are using any organization network Wi-Fi, so they may block the this AMD download thing. So because of that, you may face in the further steps. So after this pattern create, we are going to configure the root affairs and boot and kernel. And during a pattern build stage is while you're downloading the SD cache, download images from the AMD website. So it may block the some files. So and it may causes the pattern build errors. So yeah, so that's why previously I shown you the Pattern's website to download this SSD cache. Yeah. Now let's go with the Pattern's create. Let's create new project here. I am going to the projects folder. The projects. Yeah, for that Pattern's create and type project, and I'm sourcing the uh, here I need to source the BSPT and the BSP package. As if you see, my BSP board package is here under the projects, and also I'm just giving this directory projects and the Xilinx TRDBS was source, and then just giving the project name as a uh, DPU handwriting, and this is it, recognition recognition. Yeah, now just enter. The project was created successfully, and then yeah, now just enter PetaLinux config, and and get hardware description. And here you need to give the XSF file which you are getting from the Vivado. So now let's see how the bitstream is being generated. So yeah, now you can see the bitstream is successfully generated. Now you need to export the block design. Click on export block design, and here I'm going, sorry, not you need to export the hardware or block design. So click on export block design and next, and you have to include the bitstream along with that. And click next, and my export path is to the handwriting here, and actually, so yeah, and yeah, handwritten design and hardware wrapper here. Next, and just click on finish. And now if you see, hardware wrapper was successfully created and generated. Now we are going to uh, have this path in the hardware description, so that we have under the, since we have that in mount e drive and return, one second. And so here my hardware wrapper is in this mount e drive, right? So here I have this path file, and so here I'm just copying this file, Control C, and just paste it here and just click enter. And now we can, oops, sorry, here it's showing. I just went to the different project file path. So just make sure here I'm the same project file path. So this is my project file, hardware file path. So I'm just again running this PetaLinux config command, and yeah, now you can see it is creating. And here, what are the bit file you have included in, have in that in the XSF file. It is being converted to the system.xif file, if you can see here. So what are the file names? So the patterns will take as the system.xif file. So yeah, and it will generate it. So once you're done, it will pop up like this, and you can just move using your arrow keys up and down and so left and right to navigate to this. So now we are going to since and also I have to want to mention this thing that we have taken the ZCU102 board support packages. So we need to change that to the ZCU104. So here go to the board settings and just change that to 104 and click OK, exit once, and then again go to the DTZ settings, and here just change name to the ZCU104 and click OK. And also here, if you see here, it uses the, you can see that it uses the serial terminal and TTY PSU and baud rate of 115200. So yeah, let's go back and let's change the other board rail exit. And next we have to go to the firmware version configuration and just change to the, let's see, 104 here. Okay, and then here for okay and exit. Now one more thing, MS practice configuration. Yeah, just make sure since we are using SD card for the to the flash. So you're just going to select this command and just click select. And yeah, finally for the booting, it is going to generate image.ub file, and then yeah, and you have to disable this copy final image TP boot, as you may gonna face some errors here. And there, finally, all the root file systems are going to be uh, for compiled to this JZ file format external force. So yeah, and then finally to boot your ZC104 board, you're gonna need to divide your SD card to the boot partition, FAT32 format, and your second boot partition to the external 4 format in order to have the root file systems. And yeah, that's it. Now let's just exit the, just click OK. Yes. Yeah. Now the configurations were saved, and then in the Yocto build system, we need to add the meta Vitis AI layer. So the usually in the board support package we have the DN and DK layer, which is was which was deprecated, and so here for the new version of this white MetaVitis AI, we're gonna need to install it. The Vitis new MetaVitis layer. Just use this command. And also, I just want to mention what are the commands which I'm using. Everything was available in this GitHub repo file, guys. So if you can see all the GitHub MetaVitis layer, all the path files, everything was available here. So it was downloaded. If you see, uh, let's, rest. So here, if you see, MetaVitis layer is here. MetaVitis layer. I just want this path so that we can add this in the uh, file name. Yeah, I just copied this file name. Now, yeah, now let's add this to the config system, config, add this layer, and for this we need to go to the Yocto settings, user layer, and here you're gonna need to copy paste here and just click OK. So now you can see it was added, and then yeah, that's it. No what else? And yeah, here if you want to, as I said before, previous I told you guys to download the SD cache. So if you want to go for offline build of your PetaLinux, then you can just need to enable this by pressing Y, and then yeah, and just disable the network by entering N. And yeah, if you just go to the app premier and here you just need to, as if you see previously it is taking the downloads from here, or if you download it, or if you offline download this package, this thing, this downloaded, and what the downloaded file path location, you can just replace it here. Simply you can just exit, and SST feed cache, that one, the file path, you need to add it here. So yeah, so now let me just go through this build only on and when. So if you guys want to go to the offline side, choose that part. That's the way, and just save it. And yeah, just skip this part. And then exit, yes. But this config won't take much time to build it accurately. Now, yeah, now we gonna need to change few settings. So for that, you can just go. If you see the Ubuntu, whatever the Ubuntu files we are having here, you can just go to the Ubuntu, and if you go to the home and Mukesh, and then if you go to the projects which have been created, see we have the project which we created here, the Windows file systems, and yeah, here we have everything. And for the since we didn't have the DNDK packages here, it will be manually mentioned here. So for that, we need to remove that DNDK package in the bitbake file. So for that, we need to go to the bitbake file. So to remove that, you need to go to the components and Yocto layers, PetaLinux, and recipe course, and go to the package groups. And we're going to find package groups, PetaLinux, Vitis AI. Here we got this layer here, and let me edit in the notepad. So yeah, just simply remove this line. That's it, and just click save this. Yeah, and now go back to the file systems, and yeah, we need to change one more file system for the video processing system. So for that, uh, let me go back to the terminal, and let me create for the OpenCV. You just need to create this metadata. Go to project back, and here just create the OpenCV folder. Sorry, here I didn't change my favorite path here. So this command which I'm just directly copying from the GitHub. So even you guys can find the all the link all the commands from the GitHub repo. So yeah, so the OpenCV was created, and after this, when and let's open the file with this. Okay, and now click I for go to the insert mode and just copy paste that these lines and click escape and enter refine WQ to save and exit. That's it. Yeah. Now let's go to the now we'll go back to the file systems, and here I want to read the uh, add the additional packages. So for that, I'm just go back to the main systems, and then yeah, let me go to the project specs and meta users configures, and yeah, let me. I just want to read this file to add additional packages. So here already we have the GPEG and PeakPoke. So I'm just copy pasting this. So yeah, these are all the additional which I want to add in the system. So yeah, now let me. So yeah, so before going further, and also we need to enable this all in the root file systems. So before going further, I also want to change the. Oh no, this one. Yeah. Before that, let's change the device tree to device tree and this BSP package also let's configure this to whitelist the G streamer. So for that, you need to add these extra two lines to whitelist this and just click save. And also let's edit the device tree file too. For device tree is also available in this. Let's meta users, SPBSPs, device tree files, and this system user file we need to change. So yeah, here already we have since we have these many entraps number because of I think this default it is using the interrupt of 4 DPU cores, so that's why it is creating like this. So yeah, we're gonna to change this DPU address here and interrupt number ID here. So yeah, so for that we need to go back to the address editor here and let's find what is the DPU IP base address. So here DPU IP base address is H double zero double zero. So yeah, so let me just so whatever the provider I provided in the GitHub repo, I think mostly everyone will be generating the 8000. And here we need to disable this 1.8 volts. So in order to avoid the error in the PetaLinux booting. So yeah, just click save and next settings. So for that's it. So we can just proceed for the PetaLinux configuring. Rootfs configuring and just PetaLinux config c rootfs. And now yeah, so here previously we added the multiple user packages. So let me just enable those. So here we added this, and now here just press Y to enable Y and to disable and exit. And let me see here. So yeah, user packages. Yeah, so here I'm going to enable all which I enable. So we have the partner one, and we have Vitis dev. Vitis dev we don't. Yeah, we have Vitis dev and Vitis AI we have. and Vitis itself. What do we have? And OpenCV that we have, OpenCV we have, and yeah, and this we have, and OpenCV we have, and so Mega drivers we have, and EF2 those strings we have, DNF we have, and CMake also we have. So we have these all the packages which we added in here and just enabled all which we are here. I'm gonna click exit, and then let's go back to the images switches to disable the drop beer and enable the OpenSSH, and also make sure enable the package management and debug things. And if you just press the auto login here and no need to enter the password and root for the uh, PetaLinux in the JetCU board. So you just will auto login in that. Just exit and go to the file system packages and go to the MISC. And here also just as here also we need to disable the package core SSH drop here. And just go down. Yeah, SSH drop here. Here we have and just disable this. And here click exit and let's go back to here. Let's go to the console here and go to network, and here we need to go to the OpenSSH and just enable OpenSSH here and SSH, SSTP server, SSHD and SCP to transfer the files and SFTP server. Yeah, I think so far that's it. Nothing much we require. That's it. And then in this we can enable yeah, go to utils, and if you want Vim editor to use, you can just enable here, and yeah, there we have many options to zip files and what are the features you want in your particular text, you can just enable here. Yeah, and let's enable the GStreamer here in the package groups and go to the GStrips, and yeah, just hit enable it. Already is enabled, and just make sure it's enabled. That's it. That's it. And yeah, that's it so far. Yeah, if you want the enable GPI, I got demo. Yeah, so far I think this we are done with this. Yeah, here I can show you the root password of the root. Or if you want to add extra users, you can use the add extra users, and here it means the PetaLinux is the username and PetaLinux is the password as well. So yeah, exit, and save the configuration. And yeah, next we are going to the PetaLinux uh, config kernel. So yeah, I think this process is step to load. It may take a lot of time to load it, and yeah, I think yeah, if you added the if you take chosen the what is this offline mode of the PetaLinux download. So as here it is downloaded with the SSD cache and all recipes. So the process, the kernel process will be faster, and also it is only for the one time. So only once it is downloaded, and if you want to re-config again and again, so the next time it won't take you much time to load it. So now let's wait for the kernel to the load. And also in the meantime, if you want to feel the Ubuntu feel, I mean Ubuntu environment, feel that this terminal, and you can just change your appearance. And yeah, these settings will be open when you press Control, comma. And yeah, here let's choose the Ubuntu environment so that we can just get the good feel of using Ubuntu. Yeah, here you can all change all the formats here and just click save. Sorry, it is not being saved. Click OK. Save. Yeah, yeah. Now we got the good mode of using this. Yeah. So in the meantime of loading this kernel, we can install the Docker where we're going to install the Vitis and run with it. So let's take the new Ubuntu tab and yeah, here you can see it and record. And if you see my documentation here, one second. And so just follow this document flow. So from this you can get the Docker installation. Just run this, so it will just run the GPG key, and then here it will get this Docker repository get added, and then yeah, so successfully Docker will be added, and yeah, here you can see these are the commands which should be using to the pull a image. So, and we are going to pull the Vitis AI image. So run these commands in the meantime of kernel being loaded, and then to make sure Docker is successfully run. Just run this docker run hello world command. So it's gonna print you some data. Let's see whether my Docker installation was successfully done or not. So yeah, here it show me hello from doctor. This message was showing the installation appear to be working correctly. So yeah, I successfully installed my Docker. Now let's go back to the kernel where it is pop up the kernel config UI. And now we can guys see here. Here I got some few warnings, but these are going to be errors because my I'm using my organization network, so which is blocking these two download from that. Now I'm going to change to my mobile network so that I won't face these issues. So yeah, if you guys facing such issues, just try and changing the network and make sure it is not blocking. Or you can just go for the offline download where I mentioned the steps before while configuring the PetaLinux initially. Yeah, now we can see it is being loaded now. Let me zoom in. Yeah, I'm having some trouble zooming, but let me just go for this. Anyway, we're going to just config only just two steps. We're going to disable the CPU power management. So just scroll down to the CPU power management and then click on the CPU idle and then and press N to disable the CPU idle PM support. Exit and go to CPU frequency scaling and press N and exit and exit. That's it. No more much configuration changes and click S. That's it. And yeah, so far we have done the patterns configuration. Now we are going to build build the PetaLinux, so which will compile the kernel device tree and root file systems based on the hardware which we configured. And yeah, and it will take some time depending on your systems. So let's run the PetaLinux build command. So once you exit from the kernel and gonna take just few minutes to load to complete the process flow. And let's wait for that. Now you can see Kernel is successfully configured. Now let's run the PetaLinux build. So yeah, PetaLinux build. That's it, guys. Now it will build all the files, and it's gonna take too much of time. I think most probably it may take some 4 to 5 hours, depend on your system. Since my system having 8 cores, so it's gonna take some 3 to 4 hours or more than that. And yeah, and suppose if you guys are using the uh, virtual machines, so and if you're gonna take the 2 cores for the virtual machine of the Ubuntu, and it may take even a day to successfully build the image. So, and then, yeah, but, and why I'm using this? Because now my system having 8 cores. Now it will take 8 cores and it will run the 8 tasks parallelly while building. Or if you're gonna go for the offline building of PetaLinux, so it may run faster. It won't take like hours to load the image. And yeah. And now, yeah, ensure you have the proper internet connection to build successfully. And apart from that, now in the next step, we are going to package the total Linux and we're gonna install the doc. As we already installed the Docker, we have seen the few past steps where I showed in my GitHub repo. So install once you're done with the Docker, and then we next go into the Vitis installation. So I hope you guys successfully install the Docker since it's going to take a lot of time. So now let's go to the Vitis AI environment and let's completely set up that environment both parallelly. So in order to just save the time, just go into Ubuntu, new tab, and now we can see in my GitHub. So this is a Docker installation, and my Docker is successfully installed perfectly. And make sure if you just run this sudo mode, sudo add Docker as a user in that, and only to add the run with sudo every time you're done. So yeah, so if you see here, so here we're using Vitis AI multiple times. I mean, sorry. So we are using Vitis AI, and for every different versions of Vitis AI, we are having different tags of Docker. And from the link here, which will go through this, and if you see for the different versions of Docker, you can have different uh, images pulled in from for the Docker. And here we are going to pull the Vitis 1.4 version. So this we going to copy, and also here this there is what amendment here, and just copy that and pull this image. And also here this going to download a lot of stuff. I mean it's gonna download some 25 to 30 GB approximately, and even this gonna take a lot of time to build. I think approximately some 40 minutes to complete this. And yeah, already I pulled the Docker image already, so that's why it is showing me status as like this. So if you guys newly pulling the image, so it's gonna take a lot of time for you guys to run this. And also, I want to mention this that if you guys are using, if you have the GPU, you can just pull the GPU image, or if you have CPU, pull the CPU image. So based on that, accordingly, change this command accordingly. And then now, yeah. So let's pull over the Docker workspace. So for that, let's create new Docker workspace for that. So here already, if you see here uh, in my folders, I have created, or let me create one new Docker workspace here. Let me just navigate to this my projects. So I'm just creating here a new Docker workspace. Yes. new Docker workspace I created, and I'm going to use that Docker workspace as this here. And yeah, and so my Docker workspace is in this directory, Docker run and container, and this is a container and my pull image. So where I'm pulling. So yeah, now running this. So now it will load the Vitis AI 1.4 environment. So yeah, so once this is done, so let me just activate this conda activate Vitis AI TensorFlow. Now I can see this, and now so now in my GitHub repo already you can find a Docker workspace. Download this Docker workspace. So we're going to create the container on this Docker workspace. So I have downloaded, and if you open the Docker workspace, you're gonna have these files, and I just want you to just delete this quantize model compile model, because the steps we're going now, first we're going to train the model, and then we're going to quantize the model, and we're going to compile the model. Since we're going to repeat the steps again, so whatever you download from the GitHub repo, so you just delete this, and also this is the frozen model which we're going to froze, which you're going to we are going to generate it again, so you can just delete this, and yeah, levels also it's not required much, so let's delete all. And yeah, let's see how to use the Vitis AI to compile the model, train the model, and everything. So now I have this Docker is in my projects folder, so I'm going to taking that as a user workspace for my Docker container, and let me run my container. So according to your Docker workspace path, I did this, and yeah, now let's run the Docker, and it is just gonna take just few minutes to just load the Vitis AI 1.4, and then we're going to quantize and compile. And so yeah, so now we're going to use the TensorFlow one, the what are the model which I tried is on TensorFlow one. So I'll just copy this and conda activate what is a TensorFlow. If you want to use TensorFlow 2, you have to use TensorFlow 2 one. So yeah, let me activate conda activate one, and then let's see how it looks like. So now I've taken to the workspace here. So let's cd workspace. Sorry. Now you can see the what are the folders I have, and I got into this workspace folder under this. Now I'm going to train my. Before that, let's see what's there in this the train code digital model.py. So if you see in the code, we have the TensorFlow and Keras, and here we're using MNIST dataset to train the model, and yeah. So and then here we are loading and pre-processing the data. And then here we are running this CNN model and with the input nodes of input and not, and yeah, these are the placeholders for the input images, and which is required for the TensorFlow one. And then yeah, so here the final output will be the logics for the. So this is the final unnormalized output before the softmax, as we have seen before. We, as I mentioned earlier, so the softmax will be using in the CPU side of the ZC board. So there we're going to use softmax. So yeah, so output will be in the logic nodes. And then yeah, next we have the performance metrics to train, and then yeah, finally the model is going to train here, and the epochs I'm running the five epochs here, and then the finally the model is going to be saved in the .pb file frozen graph. So and then yeah, here just a normal metric just to find the total average run throughput of the image so that we can compare with the CPU and JetCU on the JetC DPU actually using DPU solution. So yeah, now let's just run the model. So I'm going to use Python visit model.py. Yeah. So now it will load the model, train the model, and you can see the epochs, so how much it is being loaded, and it's gonna take some time to run the epochs and everything. Let me see. Till then, let me pause this recording. And while you're watching the video, sometimes you may see my flow is very short, but actually I'm pausing the recording there so that the video won't be the much longer. So maybe in real time, few steps of what I'm implementing, it may take longer than you watch. So make sure and some few steps are really gonna take a lot of time. Just be patient and let it load properly. So yeah, here model is being trained, and after that, uh, it will run the five epochs as I mentioned. If you want to improve the accuracy of the model and just increase more the number of epochs so that it will train more and more. So now let's see how our PetaLinux build is flow is going on. As if you see, yeah, so far it was just only 12% was done. And as if you see, I have eight cores, so only eight tasks are being running. And suppose if you're using virtual machine, if you have only two tasks, only two tasks will be running in parallel. So it's gonna take a lot of time more than that. And if you have 16 cores, then well, yeah, it's gonna make you run tasks much faster. So yeah, so let this be run. Let's wait for the for hours. So it's gonna train model. So in the meantime, just grab some coffee, just take some break. And also, I forgot to mention that it's gonna take 60,000 images for training and 10,000 images for the uh, testing of the image. So yeah, let's see. Yeah, now we can see the model was successfully trained and it generated the model that distribute uh, the kernel in that. And let's see. Yeah, so it just successfully saved the frozen model in this. And yeah, and also you can inspect the model, the word of the nodes, the output nodes and input nodes using this command. And since this is the path and wait, so yeah, let me just copy paste and yeah. So yeah, we have TensorFlow, quantization, inspection, and then here you can get the what are the nodes, what are the input nodes, what are the output nodes of the frozen graph. So yeah, so after this and for the quantization, we're gonna need uh, the cali the calibration. For the calibration, we're gonna need the data sets and that for that to generate the data set of the graph of, and we're gonna need 100 to 1000 units. So for that, already I had the script in that. So generating calibrate images.py. So we're gonna use that script and gonna generate some 100 data sets of images for the calibration of this. And if you see here the input this frozen graph, this input and the shape of the Trained images are this, and since 28 was 28, and it's one shape, so grayscale. So we have this, and yeah, output name is logits, as I mentioned before, and these are the all operations which were performed in that. And yeah, so now let's generate the generate calib dataset, python dot py. And yeah, but let me see the what is there in the so Python and Notepad plus plus. So yeah, here we have this dataset and color images, and yeah, and here we're going to generate 100 images if you want to touch 1000 or something, whatever the number. You can just change the number here. You can then just get that. Now I'm going to generate the color images. See. Mm. So model is saved successfully. And also, if you want labels, the code, if you see my code, I just comment that if you want labels of the particular images, actual labels, so you can just remove the comments and you can just print get the labels also. So yeah, so, and finally here the main thing is we're gonna need a input function. So this is the input function. So I will show you what is there in the input function. So according to our model which you are going to train, what image you would want to pre-process. So that will be using for the quantization. And this input function code directly I just taken from the Vitis AI documentation. There they did the three like RGB image animation, but I didn't made some much changes in that. As if you see in the code, I just taken the just given the what is calib images data set where it is there and label dot set. And in the label dot text, actually we're gonna need the images. Uh, I mean the image caption names what were there in the images. So that I'm going to show you image net list. I'm just going to rename and let me generate that list too. So that when yeah when going for the batch size of let me change it to 20. So since we have taken 100 images, so we're going to take I'm going to take a 20 batch size. And next yeah and input height and output height. Yeah, reminding this is the pre-processing of the image, cropping if you can see data. So essentially it's loading the data and then cropping and size, resizing everything, and the final pre-processing of the image. So yeah, and in the this is the example code which was given from the uh, YT's documentation, and here just changed the channels. Since before they did for 3G RGB, so I just change it to one. So yeah, even I can just minimize it and just give the direct input function. So, but yeah, here is the main function which is being loaded, and then yeah, and here in the X, so here I need to change the name here because if you see here, the input name of this is input. So I need to give that input name here. So input, I'm going to change this to input. Yes, input. So the yeah, that's it. So now we're going to get that. So now let's run this. Sorry, I just forgot to save, and then let me go to this. Now if you see the documentation, my documentation. So here, this is what the flow which we're going to do. This paste anyway, and yeah, here I'm just going to change a few things since I gave the cal iteration, and actually here I need to change the calibration here. And wait 1 second, just getting. Actually, here before going the further, I didn't generated the labels, so which I need to give in the input function, so that we are going to generate that image net. Yeah, so I'm just generating the list images here. So now if you see in documentation, just refresh image work list. So all the image, all the image file names, all the list I'm getting. So here in the quantization, you have to give that particular list of that. And this is the Calib images which we generated. So this names, images, name, file names which we generated. Now, yeah, so now let's run the quantization. So yeah, so I'm just copying from that GitHub, the same, and yeah, just make sure you make changes according to your file names which you guys given, and maybe in my document the file names are different, so make changes, make sure of your what you guys giving. And so yeah, since here I mentioned the batch size is 20 there, so it's 100, so number of iterations should be 5, so 20 into 5 are 100 images total. So based on that, you have to do the calib iteration number here accordingly. Since I don't have no GPU here in my PC, so I'm giving GPU as 0, and these are the input shapes which I'm giving. And yeah, so let me run this quantization now. I mean, yeah, it's not gonna take much time as like others. So yeah, if you guys see here, uh, 5 iterations were run, and then quantization was saved in this. So yeah, now successfully it was done. Now let's go to the next step, which is the Vitis AI compilation. And if you see the difference between quantization is Vitis AI, Q for quantization, and then TensorFlow. So for the same thing, for the compilation, we have this compare and then frozen. Yeah, let me just copy this first. Just anyway, and then yeah, so depend on the architectures you have. So whatever the IP you're gonna add, it gonna show you here like this. So what are the in the whenever you pull the images, so there you can get this all these DPI which or what are the IP we have chosen, everything will be generated in this. So and also you can have you'll be having different boards. So, okay, let me just complete this, and I will let me navigate to that path so that you can see what are the boards which are available. So yeah, here the model is compiled, is saved and saved, and finally we generated the X model. So this is what the model which is gonna going inside the JetCO board, which we're going to run the model on it. So yeah, before that, let me just go to this quickly to this. Uh, yeah, really, if you see here, we have different boards, KC2, KC260, and so the Vitis 1.4 will supporting this particular whatever the packet, what are the images we pull, so that contains these boards, and this Vitis 1.4 will support these 3 boards. So based on that, you're gonna make sure which version or which IP you gonna make it compatible, and you want to run the, and which based on the which model you want to run. So based on that you have to choose the IP. And if you see a DPU seizure is for the image processing. So for the different models there are different reasons which you can find it in the documentation. So let me just go back to the workspace. And now let's see if you have see here we go, we have the compiled model here and then quantized model here. So yeah, finally the work is done. So now we're gonna share, send this compiled model. This one's compiled model, and yeah. So we're gonna not only need this X model file into the JetC board, and then yeah, and let's have some. Let's this Cal image from this Cal image. Let's take few of 5 images to test the to test the model on the JetC board, and yeah, for that and also we're gonna send the uh, whatever the files we want to share to the target board. So we're gonna send it through the SCP using because it is a fast and easy process. So yeah, if you just come here, compile model. So I'm just making a shared folder which we're going to share it to the what is this? Share it to the jet, sorry, target board. Share, just click this share model and then let me just keep it in this. Okay, and calibrate a set. I'm just taking this few some 10 images. So yeah, just copy paste it successfully and let's keep it aside so that we can share later safely. So now next, as I mentioned, we're going to share it through the SCP. So these are the commands to share. So, but yeah, we have other flow that I'm going to share how to share it through Windows or through Windows SCP. And yeah, so before going to do this step, and still I think we forgot about this. We are still running the PetaLinux build. So from this we are going to get the boot images and everything. So first we need to send these boot images and the rootfs files, and then we're going to going to the further step. So let's wait till the PetaLinux build is completed. And yeah, for you guys may gonna take too much time. Just wait till it done, and we're gonna be done. So yeah, so I think it's gonna go be take too much time, but for the video record purpose, made another project to make it ready so that I don't need to wait just for my purpose. So but for you guys, just gonna be build it like that and finally. So I'm just canceling this process in my system, and now yeah, let me just go to the so that I can show you the steps how it works. So I'm going to the other project which was already built till build it was done. So I'm going to the next step, how it gonna the next process is going to be done. So the project is already I just made this DPU. Yes. So in this, let me show you how the build successful build will be showing up. Linux build. As if you guys can see here, if once already built and if you're running this for the same project, if you're building again, so it's gonna just load it as much faster as like this, and even if you go for offline, and it gonna load as fast as like this. So yeah, so once you build successfully, it's gonna show you the successful build project as like this, the info like this. So yeah, now the next step is If you see CD images, images, Linux, if we go to that project directory and let's see what are the files we have. So for the image booting, we need this image file and boot.scss file, and the final and the root file systems will be we are going to extract from this file. Yeah, but we don't have the boot file, boot.bin file. So to get that boot.bin file, we gonna uh, package it so that we'll get the boot file. So after going to this directory, I'm running this command package and this zinc elf file which we're getting from here, and then system.bit file, the hardware bit file which we initially, if you remember, we are from the wrapper we are getting that. And also here I want to mention one more thing. And if you're changing your hardware, simply just by sharing this system.bit with your own bit file, you can just replace it from here directly, the file path, and you can just upload the from here. No need to again rebuild it again, getting hardware everything. It's not required. So yeah, now I'm just running this is to get the bin file, and yeah, it won't take much long time. And yeah, so bin file is ready. Now if I say this, if you see after the packaging, you can see the bin file here. Now we need to copy bin file, this bin file, this SCR file, and image file, and this device tree file, and then what else? Yeah, and these all goes to the one partition of the boot partition, and then this rootfs file will go to the external for partition. Okay, so actual problem of using this Ubuntu from the store which I installed, which I shown you previously. So the issue is the Windows can't detect the external for partition system. So for that purpose, I'm gonna use the uh, virtual machine for that. So in the virtual machine, I'll make my SD card mount on in my SD in the virtual machine, and then there I'm going to do the partition and all. But what advantage of using this Ubuntu on the Windows is to, if you see the I task are being parallel, but if you see for the uh, for this I have only two process code. If I go into further four processor cores and all, my virtual machine is getting stuck. So I found this is much better. And yeah, for SD card I can just share the files and I can just upload it from there. So yeah, my now I'm opening my virtual machine. Yeah, now from USB already my USB driver is connected already to that. So I'm just mounting that on the so that it will show in the my virtual machine. Here's my virtual machine, and yeah, open terminal, checking whether my it was loaded or not. Yeah, if you see, this is my SD card which was mounted. Oh, since already I have the partitions in that, so I can't able to see the total. My SD card is 8 GB. So let me just run this command to just let me delete the partitions, and then I can show you guys again the partitioning again from the beginning. So yeah, so when you run this command, it will show you pop-up like this, and if you just enter P, you can just enter as you guys. I think yeah, it's fine. Yeah. So if you just enter P here, and you can see my SD card is already partitioned. So I'm just gonna delete it again, delete the partition, and just enter one first partition and delete, and second partition, both partitions were deleted. If you see, there's no partition of my SD card. And yeah, let me see how it is there. Maybe I think I need to delete the previous files and all. So I'm just gonna format it. Let me just exit this. And yeah, before that, let me format my SD card. So already previous my files were there. So for formatting, first we need to unmount the sorry, the comments are in my documentation. You can just follow. Second unmounting, and then for fat partition, I'm just gonna run this. And also, you guys have already may have some doubt since already I deleted partition. Now I'm again running, but there I deleted partition, but I didn't save the partitions. Okay, whatever the deleted, I didn't save that. So that's the advantage of that. Even if you do that, it may not agree that. So yeah, just enter, enter, enter. Yeah. So yeah, now I'm just getting the this bin files from here. So I'm gonna need this bin file, boot, and then this image file and system.dtb file, and then this root of this partitions. So these files I'm gonna need for my partition. So I'm just copying it, and just let me just create a new file. Yeah, share to Ubuntu, Ubuntu virtual machine. And here I'm just copying this file so that I can just share this complete folder to that. So now you guys can see here I have my Ubuntu files which are just loading. So now we are going to boot to the SD card since I think these are in the Ubuntu folder now. So before going to that further, now let's just see how our partitions were. Yeah, see, we just see 1 GB is there and 64 GB one responded to STB1, STB2. So yeah, so before booting to that, we need to create the boot and mount partition to just make it to the that, and just let me just create this make boot partition since already have created before showing for me like this. All file exists, so for it won't show if you're creating for the first time. So yeah, so now I'm going to mount the STB1 partition to the to my boot. It was mounted. Now I'm just copying the boot bin file and boot SCF file and image file and system.dtb file to the boot partition, and after that just unmount that partition. Now mount the second party. After that we have to mount the second partition. It's showing something other error, wrong if it's type errors. There is some, I think, while creating something mistake I did. Let me just clear that. And for me, I think everything is fine. So for you guys, may not show you that it will show you nothing. Everything is fine. Everything is clear. So yeah. So now let me. It was just mounted, and let me just clear. With this root file system to the mounted, and yeah, it is fine. Since the before error, what I got, maybe you may not occur, but according to Maya, that is just a simple warning, some info which I got, so that is completely fine. Recording unmounted and close it. So successfully we have done the SD card data sharing. Yeah, so now you can remove your SD card and keep on your JetC board. So now if you look at to the JetC board, so let me just open the JetC boot options. So there you guys need to change the switches mode to the boot mode. Now let me just where is the SD card image? Let me just show you this image. Um, if you guys see here, we have switches here. So here in the first switch, just make it up and remaining three switches down, so that that C board will go under the boot mode. So after that, just open the Terraterm, or you can use Terraterm, or you can use Putty, anything as per your wish. Or you can just use the say screen in the Linux terminal. So as I said earlier, it is going to be baud rate of 115200. So let me just enlarge the screen. So yeah, now I'm just turning on the my ZC104, and you can see the booting here like this. So yeah, it's gonna take some 2 minutes of time to just boot it completely. And yeah, so in the meantime, just as I mentioned you before, just keep it everything in a shared folder. Yes. Uh, yeah. So now we're going to share the compiled model, which is a .x model, and some set of sample images. And before that, let's configure the Ethernet IP. So for that, if config 8010.10.10.2. And now we can see, so we have configured the static IP of ZC104. Now I'm going to configure the static IP of my PC. For that, we go to network and internet, and then we use status and networks, and then click on change adapter settings, and just click on this Ethernet and go to properties. And now we can see here internet protocol, just click on it, and yeah, just configure the IP. So maybe in your case, it may be click on the obtain IP address automatically. Just choose to the use the following IP address, use manual address, and just configure the IPs like this 10.10.3, since I gave point 2 to the that keyboard, and this point to 3 to this, and gateway 10.10. Yeah, that's it. And then next, just click OK, and yeah, close it. So yeah, so for the communication, we are using sharing through SCPs. So if you guys have the Linux system in your PC, Linux OS, then you guys can use the SCP command, which already I given you detailed in my GitHub repo. So otherwise, if you are using Windows, I think this is the best uses. So you can just install this WinSAP. I can just download it, and here already I have downloaded that in SCP. So I'm just opening this. Just click on new connection. Yeah, and just here, just choose, and here under this, just choose the SCP here and give the host name. So I'm just my target board that C104 IP is 10.10.2 and then port 22. Just keep it like that and use my username of the that C board is root and password is also root, and then just log in and click on update. So here I will get the PetaLinux and root users of this. So here you can see two two users PetaLinux and root, and so let's do it everything in the root users. So yeah. So yeah, now finally, actually yeah, before that I forgot about this, and we need the inference code for this, so that available in the my GitHub. So here you can see ZC10400 and is that recognition. So those are the files which were present in the ZC board. So yeah, so if I open this, so you can have the inference code here. So that so which is going to be run on the ZCU 104. So yeah, since already you guys had the compiled version, the compiled model and images, sample images here. So which already you guys generated your own .x model and here. So let's copy that inference code also to here, and let's all three together we can share that to the that C board. So I'm just gonna copy the inference code C++ file to. So here I copied by inference code also. So yeah, so actually this is now currently it is inside the Ubuntu since we created this Vitis environment and all that. So I'm just going to share this share folder to my Windows. So now I just copied to the file to my E file where I previously created the hardware and all. So there I created the share this share folder. So now from SCP, so using this SCP, so here if you guys see, uh, if you guys see from the E folder, I'm just going to the handwriting design recognition folder, and from here I'm just sharing this share for. So before that, let me create one new folder here. Instead of that, let me just create through the terminal here. So make directory of handwritten digits recognition. Yes. And then, yeah, let me see here. It is created or not. See, if I just refresh and so on that road, we have this and PWD. See, we are under root system, so this is the best option to use the best application to use this. So now I'm just simply uploading the file to the Let's See board. Yeah, sorry, I need to share it under this folder, handwritten digits. Oh god. Okay. Let me just for the proper flow. So yeah. So now if you see, we have, now if you see we have the C++ file and images and compile model and all. So yeah. So now the next task is converting the this C++ inference code to the binary file. So before that, I want to explore the what is there in the C++ file. So yeah, so in this code is depending on the OpenCV libraries for loading and pre-processing of the image. And for running model on the DPU, here we have the wire and the TensorFlow buffers for pre-processing of the data and executing on this model. So, and then next we have the here we have one class of TensorFlow buffer. Simply can be say just to allocate a memory for TensorFlow data and implements the data method to return pointer and sizes as simple class which are created, and then yeah, next we have the uh, as you see here it expects these three arguments as I mentioned before. For this we need three files. One is binary file which we're going to do in the next step. Second is the model.x model file, and then the third input it needs is the image. That's it. So after that, it is going to next deserialize the model. So by so here it what the load and pre-processing of the .x model file is going through, and then here it is now here in the runner command. So it it will finds the DPU subgraph for the model to assign to run on the hardware. So this is the main function which is going to be used for that. And yeah, next is the processing. Image pre-processing is being done to load the grayscale image of it. And then here we have the input and output buffers. And then once it copies the image to the input buffer, then here it will run the inference on this job ID by executing this asynchronously. The model will be executing and it will wait till it finishes. So here I just had this end time, start time to measure the inference time and all. So yeah, so after that, as I mentioned earlier, which I'm going to, I told that I'm going to implement the softmax function in the CPU side, CPU of this GPU, which is PS side. So yeah, here I'm using this is the main part where it is executing softmax. And also here we have the maxer to prevent the overflow, in, like provide preventing from getting the infinite values. So yeah, finally it's gonna print the performance matrix and all. So this is a simple code which was being running on FPGA. So now let's work on what is it? Let's work on uh, generating the binary file. So for that, the command is this. So which was provided in the Git my GitHub. You can see, and so this is the file, and here we are giving the file which is this. So our file name is inference dot underscore code, and it will provide the output of MNIST model on the name of binary file on the name of MNIST model. So yeah, these are the files which is going to use for the by the compiler. So let me just click OK, and so yeah, let's run. So now it is going to generate the binary file. Once that is done, and we can run the model, and you can see the output, and it will show find and when it will show the output of the probabilities of each class. Since we have the uh, 10 digits, so we'll be having 10 class probabilities. So let's see whether its model is created or not. We see here MNIST model was created, and so I'm just running this file, manage the model, and then the second argument which you need to give is text file. So which is the model file name is, let's see here, digit digit recognition dot model, and third argument which we need to give is image. So here we give the image, and then just click on just that's it. As you guys see here, we got probability of 1 for the class 0. Let's see whether exactly is it true or not. Since what is the file path which I have taken is image 0010. So let me go to the my files. So here 0010 is the face. Yeah, so that file is, so the actual is 0 and it gave the 0. And now let me run one more two. Yeah. So second image prediction is 2, which is class 2. And if you see here, image is 2. Yeah. So we have seen the inference time, which is very low, 0.176 milliseconds, and throughput is 5681 frames per second. And if you want to see the CPU, and I can say it outperforms the CPU performance. And this is a previous screenshot which I have taken. So if you see the CPU performance is 598 milliseconds, and whereas the DPU is 0.17. So, and even throughput is, we have this 1669, and here, but here we have 5714, which is almost like it's a 3x better performance we are achieving through the DPU acceleration. And so far, you guys have seen the real power of DPU acceleration of Xilinx FPGA, and you have seen the full journey of training an AI model and deploying it on embedded FPGA system. I hope you guys like this video, and I hope you guys understand my explanation. And yeah, if you like this kind of in-depth content, please don't forget to like and subscribe. And please drop your questions or any suggestions in the comment section. And the GitHub link is provided in the description. And thanks for watching, and see you in the next one.